Welcome to the Mountain Path, the world of finance. This is Ravichandran. This session we will discuss basic introduction to the Black-Scholes option pricing model. We will also discuss the model assumptions, inputs, as well as uses and applications. We will also discuss a simple example illustration of a Black-Scholes option pricing model, calculation of call option, put option without dividend. Then we will discuss one example with the dividend also. What are all the requirements? The requirements for this session is a basic understanding of derivative options, the payoff, option moneyness, option pricing determinants, and put call parity concepts. In subsequent session, we will discuss option pricing calculation using with the yield, and we will also calculate Black-Scholes option pricing model and with the yield in percentage, implied volatility, and also we will calculate for currency options how to calculate. We will also discuss arbitrage and pricing calculations. Let's quickly go into the Black-Scholes option pricing model. Important points. So it is a mathematical model. It helps to calculate the theoretical price of a European call option. So it is primarily used to calculate the European call option. The model was developed by Fisher-Black, Myron Scholes, and Robert Merton in 1973. Whereas Robert Merton and Myron Scholes were awarded the Nobel Prize since Fisher-Black died in 1995. See, what are all the basic assumptions of the model? The assumptions are stock-based, no dividend. It is a European exercise style. Markets are efficient, no transaction cost. The interest remains constant on continuous compounding basis. And the prices, the returns are log normally distributed. The Black-Scholes option pricing model is a very important valuable tool. The model is used widely by many option traders as well as financial analysts. The important inputs for the model are the current stock price, the time to expiration, the strike price, the risk-free rate, and the volatility. The volatility normally we calculate the 1 year stock return calculation volatility, and the returns are on a continuous compounding log normal returns. And the volatility normally it will be ranging between somewhere around 15% to 65%. So we will use the annual volatility in the option model. Then the option pricing, since it depends upon the 5 key important variables, namely the stock price, the strike price, the risk-free rate of interest, the time to expiration, as well as the volatility. Of these 5 variables, the 2 comes from the option contracts, that is the strike price and the maturity time. The 2 remaining variables, or market variables, there is nothing but the stock price and the interest rate. And the volatility, and it cannot be observed directly, so we have to calculate it. So the call option price calculation as per the Black-Scholes option pricing model is the current stock price into N of D1 minus the present value of the strike price into N of D2. So whereas the D1 is nothing but the log of S divided by K plus risk-free rate of interest plus half the variance into time divided by sigma into square root of time. D2 is very easy, and D1 minus sigma into square root of time. Now let's calculate the steps needed to calculate the call option prices. First calculate D1, then derive D2 from D1, then calculate the N of D1 and N of D2. In Excel we use the norms list of D1 and norms list of D2. Then apply this the input, the parameters into the call option, Black-Scholes option pricing model calculations. Then how do you calculate put option? Either we can use a formula, put option premium is equal to the present value of strike price into N of minus D2 minus current stock price into N of minus D1. Or you can use put call parity, put price is equal to call option price plus present value of the strike price minus the current stock price. There are some issues with the Black-Scholes option pricing model. What are they? It will not work if the option is deep out of the money or deep in the money. It produces some biased values from very high volatility stocks, and also it may use unreasonable values when the option has got only a few days before expiry. What are D1 and D2? D1 and D2 are nothing but they are used to calculate the probability of the option, whether it is in the money or expiration or not. So that means the n of d1 and n of d2 is a cumulative distribution function or a standard normal distribution evaluated at d1 and d2. And so whether n of d2 is a risk adjusted probability whether the option will be exercised. So with these important things, let's discuss where the Black-Scholes option pricing model is used apart from pricing of option. So the Black-Scholes option pricing model can be used in hedging, portfolio optimization, in risk management areas, the calculation of real options, and also in structured credit risk model to calculate probability of default. So let's quickly go into a basic model, an illustration of how to calculate call option pricing and put option using a Black-Scholes option pricing model. Let's assume the current stock price is 100 and the volatility, the sigma, is 25%. The risk-free rate of interest on a continuous compounding base 8% per annum. Time to expiration is 6 months, 6 divided by 12. Either you need to use n by 12 or we have to use d divided by 365. And the strike price k is 110. So with these inputs, let's quickly calculate and the d1. The first, what is d1? ln of s divided by k plus risk-free rate of interest plus half the variance into time divided by sigma into square root of time. So let's break this d1 numerator and denominator separately. Calculate the ln of s divided by k and plus calculate the half the variance plus r of r into time. Then calculate the numerator separately and calculate the denominator separately. Calculate d1. So we get d1, you can have negative values, absolutely nothing wrong. And then d2 is nothing but d1 divided by d1 minus sigma into square root of time, which is nothing but the denominator of d1. So d1 minus the denominator of d1, that is d2. So once you calculate d1 and d2, then n of d1 is normal distribution, normal standard distribution of d1. You can use the norms dist of d1 in Excel and norms dist of d2 in Excel. So once you calculate that, the final step is to calculate the present value of the strike price, which is nothing but 110 to exponential minus and r 8% into 6 divided by 12, that is 0.5. So once you calculate the discounted value of the strike price, the final step is to give the inputs into the model, that is nothing but the stock price into n of d1 minus present value of strike price into n of d2, which gives you 4.75. Let's quickly check whether the pricing calculation is correct or not. Here, the call option current stock price is 100, the strike price 110. So by the look of it, we can say that the call option price has to be out of the money. So that means whatever we calculate the 4.75, there is no intrinsic value, it is only has a time value. So our calculation is perfect, it should be below 10. The next is to calculate put option premium. Either we can use put call parity. So put premium is equal to call plus present value of k minus the current stock price. Or we can use the formula also to calculate present value of k into n of minus d2 minus the current stock price into and n of minus d1. So you can calculate, so the put option premium is correct, and we can check whether the calculation is correct by putting into put call parity equation, which is nothing but call plus present value of k is equal to put plus the stock price. So we can see that the left hand side and the right hand side are equal. So our calculation, the basic option pricing model is correct. Let's go into the next one, and how do we calculate with the dividend? The same example, let's understand the same. The current stock price 100, the volatility is 25%, the risk-free rate of interest is 8%, and the time to expiration is 6 by 12. The strike price is 110. Let's assume a dividend of rupees 5 is payable in the next 20 days. And now we have to calculate what is the time. Time is 20 days, means 20 divided by 365. So whenever a dividend is given, first important thing, the dividend we need to check whether the dividend is payable during the life of the option. Life of the option means the dividend has to be paid before the expiry of the option and contract. So since it is 20 days, the option expiry is actually 6 months, so it is well within the contract. Now the first step is to calculate the present value of the dividend, which is nothing but 5 into exponential minus RT. That is nothing but the 5 is discounted backwards for 20 days, so that becomes 4.97. The second step is to calculate the adjusted stock price. What is adjusted stock price? The current stock price minus the present value of dividend. So that is the adjusted stock price. Now we are going to use this adjusted stock price and in the place of the current stock price in the Black-Scholes option pricing model in 3 areas to calculate the call and the put option. Number 1, in the D1 calculation, instead of ln of S divided by K, we are going to use ln of adjusted stock price divided by the strike price. That is the first time. The second is we will calculate and the call option price. Instead of calculating S into N of D1, we will say adjusted stock price into N of D1. And the third time we are going to use adjusted stock price in the, and when you calculate the put option premium, that is a call plus present value of K and minus the adjusted stock price. So we can also use the formula also here also present value of K into N of minus D2 minus adjusted stock price into N of minus D1. So the same approach in a dividend, only condition is the dividend has to be paid within the life of the option. We have to calculate the present value of the dividend, then calculate the adjusted stock price, nothing but the current stock price minus the present value and the dividend. So this dividend Black-Scholes option pricing model is actually and modified to accommodate a dividend and how to calculate a call option with the dividend. Okay. In the next video, we will discuss how to calculate call option put option price using Black-Scholes option pricing model when yield is given, yield of an underlying is given as a percentage. Then we will also discuss how to calculate implied volatility and using a Black-Scholes option pricing model. Thank you for watching. We will see you in the next video.